redistribution between RIP and OSPF. Iniciar, start. R1, R1. Configure terminal, interface, loopback 0, IP address, okay, 48, zero sería el 30, one two 1 2, click rate, bandwidth, shutdown, physical interface, R2, R2, configure terminal, interface, loopback 0, IP address, interface, serial 0, serial 3030, IP address 122, bandwidth, now shutdown, serial 1, serial 1, IP address 232, clock rate, bandwidth, no shutdown, okay, R3, R3, configure terminal, interface, loopback 0, IP address, okay, 20, 168.20. Serial 31 IP address 233. Okay. Bandwidth not shut down. This is optional, esto es opcional. Verify and use TCL scripts. Verifique y use el script TCL. R1, R1 and TCLSH, TCL shell, TCL shell, okay, and right click derecho, the only pings that you should receive back are those of the connected networks. Los únicos pings que okay, listo, ready. Configure RIP2, configure RIP2 and exit. Based on the topology, which networks need to be advertised into RIP4-1? Basados en la topología, okay, this network and all these networks, okay, this network and all these networks, which networks need to be advertised into RIP4-R2? Okay, only this and this, okay, only these two networks, this and this, okay. Okay, R1, configure terminal, router RIP, version 2, no auto summary, network, Okay. This is a classful network. This is a classful network that includes this network and this network. Okay, the classful network subnet mask is 16. So this includes this network and this network. Okay. Okay, R2 reverse exit router RIP version 2 now auto summary. Network. Okay. This classful network includes this network and this network. Okay, because the subnet mask is 16 and includes both networks. Okay. The RIP network command only requires the classful network address to be entered. So you can specify the networks. Okay. You can do this and it's the same. Okay. Or you can do this. Okay. It's the same. Okay. Verifica R1 R1 and show IP route RIP. Okay. Okay. R2 and show IP route RIP. Okay. R1 show IP RIP database. Okay. The remote networks on R2. Okay. Configure passive interfaces. R1 show IP route RIP. So serial 1 is on R2 is not participating on RIP. Should be passive interface. Notice that the network for serial interface on R2 that connects R3 is present, even though you don't have a RIP neighbor on that interface. This is because the classful B network was added to RIP on R2. Okay, verify that the RIP updates are being sent to out both serial interfaces. Show IP protocols. Okay, is present sending and receiving updates, RIP updates. And this is the classful network. Configure terminal, router RIP, passive interface serial 30. Show IP protocols and show IP protocols. Okay. Okay, should be 3.1. Okay, should be this 3.1. Okay, configure terminal, router RIP, no passive interface 3 serial 30 and passive interface serial 3.1, and show IP protocols, and 3.1 interface is not present. Passive interface. Show IP route RIP on R1. Okay. Okay, look this network, making an interface in RIP passive only disables updates from being sent through RIP. It does not affect routes being received through it. Okay. What are some reasons to prevent RIP from sending updates of a particular interface? RIP version 2 does not use an adjacency system. RIP version 2 floods all its routing updates of its interfaces rather than developing adjacencies with short hello packets like EIGRP and OSPF, because RIP could flood packets of interfaces where there are no RIP receivers. It is best practice to prevent RIP packets from being sent out these interfaces. Putting RIP version 2 interface in passive mode saves the router from sending multicast read packets out an interface that has no neighbors. Thus, read version 2 send advertisement out loopback interfaces. By default, loopback interfaces act like normal interfaces in read version 2 when sending and receiving packets. However, a router will never have read version 2 neighbors or its loopback interfaces, so loopback interfaces can always be configured as specific interfaces, thereby saving CPU resources. Okay, and R1 configure terminal, router read passive interface, loopback 0, R2 okay. An alternative to making each loopback interface on R1 passive is to make all interfaces passive with the passive interface default command in router configuration mode. Then make any interfaces that need to send updates, such as serial 0 non-passive. Okay, this is the commands R1 exit router read passive interface default, now passive interface serial 30. Okay, 30 is not passive. Summarize a subnet with RIP, show IP route RIP on R2 and show IP route RIP. Okay, look at this. Which RIP routes should you summarize because they are contiguous, and which mask should you use? Okay, contiguous 48, 49, 50 and 51. Okay, 70 is not contiguous. Okay, the new subnet mask for the summarization is 22 bits. Okay, configure on R1, exit interface serial 30 IP summary address RIP (22 bits). Okay, summary mask must be greater or equal to mayornet. Recall from the EIGRP labs that summary routes display in the summarization device routing table as having the next hop being the null/zero interface. You can create an entry manually using the ip-route command and redistribute into RIP, thereby emulating the approach of EIGRP to a certain extent. To get around the IP summary address RIP message error, create a static route on R1 to summarize the networks of loopbacks from 48 through 51, then redistribute to the route on R1. Okay, exit IP route. Null/zero router RIP redistribute static. Okay, show IP route and show IP route. Okay, look at the new route. Okay, on R2 show IP route. Okay, look at this. Okay, will this route to null/zero affect routing to prefixes with longer addresses on R1? Explain. The routing table first matches based on longest IP prefix. If any of the summarized networks are routable on R1, as in this situation, R1 uses the connected route with the longer mask to reach those networks. If one of those interfaces were to be shut down, R1 would send traffic for that network to its null/zero virtual interface. Suppress routes using prefix lists. Sometimes you may not want to advertise certain networks of the particular interface. Okay, in this scenario you want to filter updates from R1 to R2, allowing only the networks of loopback 0 and loopback 70 and the summary routes to be advertised. You want to suppress the more specific prefixes so that routing tables are kept small and CPU processor cycles on the routers are not wasted. Okay, the 22-bit summary and 24-bit major network address both have the same address, so access list will not accomplish with the filtering correctly. Therefore, it's necessary to use prefix lists. Okay, configure this. R1 configure terminal IP prefix list, the name RIP out, permit the summary with prefix 22. and deny the length 24, and deny less than or equal, okay, less than or equal 24. Okay, the GE keyword represents greater than or equal. LE less than or equal. If both GE and LE keywords are omitted, the prefix list is processed using an exact match. Okay, deny lower or equal to 24. And permit any other less or equal than 32. Line 1, list permits the summary root and nothing else. Line 2 denies all prefixes with network address. In this block that have a subnet mask from 22 to 24. This removes exactly 4 network addresses. Line 3 allows all IPv4 prefixes that are not explicitly denied. Okay, and from root configuration summarization, apply this access list with the distribute list. Root rip distribute list prefix three zero. Okay, R2 show IP routes. Show IP routes. Clear IP routes. Okay. Show IP routes. Show IP route rip. Okay, and okay, now it's ready. Why would you want to filter updates being sent out or coming in? The intention is to summarize addresses at R1, achieving benefits such as smaller routing tables and the prevention of route flapping, disturbing network stability. By redistributing the static route into RIP version 2, only the summary route was added, but the more specific routes were not filtered. To achieve these benefits, filter the outgoing routes to R2 by allowing all routes except the 24-bit routes. Okay, configure OSPF. Okay, R2, R2. Configure this network 2.3 on serial 3.1. Configure terminal router OSPF process ID 1 network wildcard area 0 R3 exit router OSPF 1 network okay. This includes this network and this network. And this includes all these networks from 20 to 40. On R3, change the network type for loopback interfaces to point-to-point so that they are advertised with the correct subnet mask 24 instead of 32. Okay, exit interface. Loopback 0 IP OSPF network point to point okay. Verify adjacencies on R2 and R3 and show IP OSPF neighbor. Okay, this is R2. Show IP route OSPF. Okay, now remote no remote OSPF routes. Okay, now remote routes for OSPF. Okay, R2 and show IP OSPF neighbor. This is R3. Show IP route OSPF. Okay, these are the networks on R3. The remote networks on R3. Okay. Note that output of the show IP route OSPF command on R3 is blank. The network 192.168.0.0 Commands allows OSPF to involve interfaces that have IP addresses in the range. A common misconception is that OSPF advertises the entire range of the network given in the router's network statement. It does not. However, it does advertise any connected subnet in the range of addresses to adjacent routes. You can verify this by viewing the output of showIP command on R2. Do you see 192.168.0.0 supernet? ShowIP route. Okay. Now, because the network command selects interfaces by IP addresses, it does not set the exact prefix to be advertised. Configure passive interfaces on OSPF. On R3, configure terminal interface router OSPF1, passive interface loopback 0. How is this different from the root version of this command? Passive interfaces in RIP version 2 prevent outgoing routing information using multicast. Because OSPF must create an adjacency before sending routing updates, the OSPF version of the passive interface command prevents sending or processing OSPF packets and therefore prevents adjacencies. Use the passive interface default command to make all interfaces passive. Then use the non-passive interface command to bring the serial 1 interface out of passive mode. Okay, exit router OSPF1, passive interface default. Non-passive interface serial 3.1. Okay, non-passive interface verify show IP protocols and show IP protocols. Okay, passive interfaces. Allow one-way redistribution. On R2, configure OSPF to redistribute into RIP under the RIP configuration prompt with the redistribute OSPF process metric command. Where process is the OSPF process number and metric is the default metric which you want to originate the routes into RIP. If you do not specify a default metric in RIP, it gives routes an infinite metric and they are not advertised. R2, configure terminal router RIP redistribute OSPF process 81 metric 4. Verify. R1 show IP route and show IP route RIP, show IP route RIP, and look the R3 networks learned by R1. Look the how R1 learns the R3 networks using RIP, but ping will fail because this is only a one-way configuration. Okay. Notice that it shows that R1 has a route to R3, but R3 does not have a route to back R1. Okay. Show IP route OSPF. Okay. Now routes to R1. You can originate a default route into OSPF that points toward R2 so that the pings are routed back toward R2. R2 uses its information from RIP to send pings back to R1. Force R2 to advertise a default route into OSPF. Exit router OSPF1, default information originate always, R3 show IP route OSPF. Okay, now it's ready. You should now have full connectivity between all networks in the diagram. Use the TCL script. R1 TCL shell, right click. All is successful. Redistribute between two routing protocols. Remove the default information or originate always on R2. Exit router OSPF1. Now to remove the line. Okay. Next, use the redistribute read command. Okay. Redistribute RIP. You do not need to specify a default metric in OSPF. Show IP route on R3. Show IP route OSPF. And look at the R1's networks. Look at the networks of R1. By default, only OSPF only accepts classful networks. Okay, only classful networks. OSPF only accepts classful networks and subnets. Okay, You can modify this behavior by adding subnets keyword to the redistribute command. Okay, R2 redistribute rip subnets. Okay, R3 show IP route OSPF. The classful and supernets and the networks on R2. Okay, and the networks on R2. Okay, all RIP networks learned by R3. Okay. Run the TCL script again. R1. Okay, successful. Set a default seed metric. Under any routing protocol, you can specify a default seed metric to be used for redistribution instead of or in addition to setting metrics on a per protocol basis. A seed metric is a protocol independent feature to the Cisco IO software that is usually configured when redistributing into distance vector protocols. Notice that the metric listed in R3 is 20. Okay, 20. You can also use the metric command under other routing protocols. In OSPF on R2, in OSPF configuration mode, issue the default metric command to configure a default metric for redistributed routes. The default metric for all OSPF redistributed routes is 20, except for BGP, which is 1. Setting the metric for RIP to a higher number makes it less preferable to routes redistributed from other routing protocols. Okay, R2 router OSPF1 default metric $10,000. R3 show IP route OSPF 10,000. Okay, and show IP routes. Look at the R3 routing table. Notice that external redistributed routes have a OE2 as their type. In the output, O means OSPF and E2 means external type 2. OSPF has two external metric types, and E2 is the default. External type 1 metrics increase like a usual route, whereas external type 2 metrics do not increase as they get advertised through the OSPF domain. Also notice that the metric is exactly the same as the seed metric in the previous step. Where would an external type 1 metric be useful? If there are multiple paths through an OSPF domain to an external destination network, use E1 routes so that OSPF will evaluate the shortest cost path. Especially use this option if multiple ASBRs are advertising the same destination network to prevent suboptimal routing. Where would an external type 2 metric be useful? If there is only one ASBR advertising an external route, use E2 routes. In this scenario, use E1 type even to only one ASBR is advertising the external routes. You can change external type using the metric type argument with the redistribute command. Okay, R2 router OSPF1 redistribute RIP subnets metric type 1. R3 show IP route OSPF E1. Okay, which attributes of the routes changed? The external route type has been changed from E2 to E1. The metric previously 10,000 has been incremented to represent the path through the OSPF network to the ASBR. Okay, thank you.